Going to discuss about the matrix is given. So in this matrix we are going to reduce diagonal form using the orthogonal transformation. In this previous class we discussed how we can find the characteristic equation, eigenvalue and eigenvector. Using this eigenvector we are going to discuss the that is pairwise orthogonal or not. If it is an eigenvector, is a pairwise orthogonal or not. Okay. So this is eigenvector 1 and this is second eigenvector, this is third eigenvector. So here we are going to check it is a pairwise orthogonal or not. In this pairwise orthogonal, we are consider x1 transpose x2. Here x1 transpose, this is the x1. We are going to take the transpose. So it is a column changed into row. That is 1 0 0. So using x2 0 minus 1 minus 1. So here we want to multiply 1 into 0 is 0. Again 0 into anything 0. 0 into anything 0. So it is 0. It is a pairwise orthogonal. Similarly we want to find x2 transpose x3 equal to 0. x3 transpose x1 equal to 0. Then we go on the third step. In this third step, the eigenvector is we are going to convert it is a normalized model matrix. In this normalized model matrix, we are going to form the normalized eigenvector. In this normalized eigenvector, we are going to using the ordinary eigenvector. So if it is a first eigenvector is 1 0 0. So I am writing 1 0 0. So here we want to using L of x. L of x. Every element we are going to divide L of x. What is L of x? L of x is nothing but every element of square and then adding. So 1 square, 0 square, 0 square. That is 1. So then we are going to divide 1. 1 divided by 1 is 1. 0 divided by 1 is 0. 0 divided by 1 is 0. So the first normalized eigenvector is 1 0 0. Similarly, we are going to find second normalized eigenvector using the second eigenvector. This is the second eigenvector. 0 minus 1 minus 1. 0 minus 1 minus 1. Then we are going to use L of x. Here we want to find the 0 square, minus 1 square, minus 1 square. Okay. So 0 minus 1 square is 1 square. That is the answer is root 2. So in this root 2 we are going to divide root 2. So the answer is what is that? 0 minus 1 by root 2 minus 1 by root 2. Similarly we are going to solve the third eigenvector. The third eigenvector is 0 divided by, that is every element. 0 square minus 1 square 1 square, that is root 2. So we are going to divide root 2, divide root 2, divide root 2. This is the third eigenvector. In this eigenvector we are going to combining these eigenvector in the matrix form, that is step 4. So in the step 4, that is normalized matrix. In this normalized matrix, first we are going to write 0 minus 1 minus 1. Then we are going to write the second eigenvector, minus 1 divided by root 2 minus 1 divided by root 2. Then 0 divided by root 2 is 0. So no need to put 0 divided by root 2, only we have to writing 0 minus 1 by root 2 and then plus 1 by root 2. So this is the normalized eigenmatrix. Using this normalized eigenmatrix, we are going to solve. It is a n should be orthogonal. N should be orthogonal. In this orthogonal, we are going to check n transpose is equal to I using this matrix. So here n is nothing but this one. What is n transpose? N transpose, we are going to change row in terms of column. So here the row, we are going to change the column as row. So 0 minus 1 minus 1. Again we are going to change the column 0 minus 1 by root 2 and minus 1 by root 2. Here also 0 minus 1 by root 2 and 1 by root 2. Here we want to multiplying this into this, we get the I. What is I? I is a identity matrix. In this we 3 by 3. The answer is 0, 1, 0, 0, 0, 1. If it is 1, 0, 0, 0, 1, 0, 0, 0, 1, n is a orthogonal. N should be orthogonal. Then we are going to move on the diagonalization form. In this normalized matrix, it is a orthogonal. Then we are going to move on. It is a diagonal form. In this diagonal form, n transpose A into n. You know n and n transpose. N is a normalized model matrix. So this is the normalized model matrix n. Then we are going to interchanging the row and column. So it is the n transpose. A is the given matrix 1 0 0 0 minus 3 minus 1 0 minus 1 3. After we are going to simplify this, we get the diagonal form. In this diagonal form, the eigenvalues are occur in the diagonal. Remaining elements are 0. Only occur in the diagonal element. These 1 2 4 is a what is that? This is the eigenvalue. So in this matrix are reduced to diagonal form. In this diagonal form, the eigenvalues are occur. Okay. So this is the method to reduce the diagonal form by orthogonal transformation. Thank you.